Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's gonna be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Edicarian fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the ice age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age.
Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time, and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop, and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures. Mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
Yep, there's ice all around, as far as the eye can see. A white desert covers the entrance to your cave, the one where you and a bunch of other settlers live. Everyone's gathered around a fire pit, trying to keep warm, telling each other stories about how much snow they saw the other day. Some are running around playing tag, throwing sticks, whatever people used to do for fun 300,000 years ago. You're one of the earliest Homo sapiens to ever walk the earth. Others are sleeping or just resting their eyes. All around the cave, all you can hear are stomachs rumbling, sounds like a wild animal lurking around. You look out the mouth of the cave and see that the storm has cleared. Time to grab some tools and head out as a group. In the open wilderness, you find some berries covered in snow and plants that might be edible. But it's not enough to feed the whole tribe. It's the Ice Age, and there's not much vegetation growing anywhere. One of your friends spots some large footprints in the snow. The chase is on. You can't tell what it is, but it should be enough to feed everyone for a couple of days. As you go deeper into the snow-covered forest, you hear a growl behind you. You hope it's your stomach, but you look behind you and suddenly black out. An ice age is a period when large sheets of ice cover everything, changing the Earth permanently. It's partly responsible for the raising and lowering of sea levels, as well as the current layout of the continents. Picture monster-thick ice sheets spread across what's now Canada, Scandinavia, Russia, and even South America. That's all caused sea levels to change drastically, and temperatures around the world fell dramatically. And I'm not talking about just one ice age. There were a bunch of them. Scientists say there have been 5 major ice ages throughout history, lasting for millions of years. And we're in the middle of one right now. Relax, don't panic. It doesn't mean we're all going to be sleeping next to bonfires, trying to keep warm after being out all day looking for woolly mammoths. And no, there won't be a massive geological ice storm that freezes everything in its path. Ice ages have warmer periods in them that come and go, lasting for tens of thousands of years. In fact, billions of years ago, the Earth was one giant snowball with no life on it. And the sun back then was also just a cute little fireball without enough heat to melt all that ice. But as the sun got bigger and hotter, Earth's ice slowly melted away, leaving the green and blue ball we have today. We're living in the Quaternary Ice Age that's been going on for the past 2.6 million years, and counting. Some animals have thrived in this latest ice age, like whales and sharks. They've been at the top of the food chain for ages. Under them are seals, certain kinds of fish, otters, all the way down to tiny plankton. Up on the cold surface, mammals had to grow thick and shaggy fur just to stay warm. Ancient mammoths, rhinos, and bison were known to have thick rugs on them. They looked awesome. They were herbivores and ate small shrubs and whatever grass they could find. But several thousand years ago, temperatures began to rise, and most of these animals became extinct. The ones that remained evolved into the elephants, hippos, and rhinos we have today. You wake up from your blackout and find yourself face to face with a creature that kind of looks like a modern-day bobcat, except it's much bigger and furrier. It's a Smilodon, an epic version of a saber-toothed cat with a mean look. It's around the same size as a male lion and has two front fangs that make me think twice before leaving the safety of my cave. They look scary, but scientists think their bite wasn't as powerful as today's tigers or lions. What made them tough were their giant forearms used to wrestle down anyone who got on their nerves. In packs, they were even able to take down mammoths. Either way, you don't want to be waking up next to this kitty. It's staring you down, ready to pounce. But you and your friends keep calm and slowly back off. You get the genius idea to throw a rock to distract it, then run. Nowadays, it's near impossible for a human to outsprint a lion or tiger, but humans back then were much fitter. Once the danger's over, everyone continues to look for food. It's getting dark, and you haven't found anything to bring back to the cave. Suddenly, you smell something burning. Way off in the distance, you see a thin column of smoke rising into the sky. Another settlement? You and your friends look at each other and approach the smoke cautiously. Homo sapiens first came into being about 200 or 300 years ago. But human history didn't just pop up out of nowhere. As far back as 7 million years ago, some of us decided to call it quits. We left our chimpanzee ancestors in the jungle and started doing our own thing. And that didn't just happen once. Over those next millions of years, there were over 20 different human species. Some were our ancestors, some were twigs from a completely different branch. Some were tiny, others better adapted for hot or cold weather. Before you know it, you see a group of Neanderthals cooking some meat, sharpening their tools. Neanderthals were the first to migrate to Europe. Scientists believe they were around somewhere between 40,000 to 400,000 years ago. They occupied all areas between Europe and Asia, while Homo sapiens, that's us, were still all the way down in Africa. You enter their camp and immediately see the differences between each other. They're stocky and look a bit different, but there are some similarities, like flat teeth for chewing and gnawing and big skulls for their big brains. They even have clothes on, like you. According to archaeologists, they lived in shelters and made tools out of stone, sticks, and bones. They welcome you inside and give you a tour like no other. You're officially meeting another human species. They take you inside their cave and show you some of their cave paintings. They were the first artists of their time. Many of their galleries are still around today, like the ones in caves in Spain. You know their style: minimalist paintings of deer, a large handprint. They also dabbled a bit in jewelry making. They made necklaces out of eagle talons and animal fangs. They were also probably the first ones to harness the power of fire. Did they discover it when a bolt of lightning hit a tree? Or when one of them dropped a rock on another rock, creating a spark? No one really knows. But they were able to recreate it and use it to keep warm, to cook food, to see in the darkness, and to protect themselves. After the nice tour, you hang around the campfire to keep warm. They even offer you some extra clothes for the journey home, mostly thick, shaggy mammoth coats. If only you could talk to each other, that would be awesome. But it's getting dark, and you need to head back to the tribe. You say your goodbyes and thank them for teaching you how to draw a deer, and for that sack of food they gave you. The Ice Age was important for the development of the modern Homo sapiens. Because of the extreme cold and other harsh conditions, they had to adapt to survive, be extra clever and innovative. They developed advanced tools and even used bone needles to sew warm clothing. They may have hosted the first ever runway show. When the climate started to get warmer, they developed farming techniques to sustain themselves and mainly settled near large bodies of water like rivers or lakes, while others opted to be near seas and oceans. They, we, were even the first to domesticate animals. Fast forward a few 100,000 years and here we are.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our Sun. Can you imagine that? It's so enormous that if we could somehow replace our Sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time.
Yep, you heard it right.
Betelgeuse is about 600 light years away from us, so the light we see today actually left the star 600 years ago. It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink, but just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? We'll get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, hey, look at this amazing spectacle. How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. stock up on essentials like warm clothes and supplies just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space.
Look at those lush coniferous forests and tundra. What a wonderland. You may have mistakenly thought it's Canada, but it's not. It's Antarctica, about 34 million years ago. So what makes Antarctica this frigid today? It turns out a mix of dropping carbon dioxide levels and some tectonic shuffle played a huge role in transforming this ice-free paradise into the frozen continent we know now. About 50 million years ago, CO2 concentrations were sky high, strutting around at around 1,000 to 2,000 parts per million. But as those levels tumbled down, global temps started to drop, paving the way for the mighty ice sheets that later took over Antarctica. While the CO2 dive was happening, tectonic activity was also working its magic. The big split between South America and Antarctica opened up the Drake Passage, which created the Antarctic Circumpolar Current. This powerful current acted like a bouncer, keeping warm air and ocean currents from crashing the Antarctic party, and helping keep things rather frosty. If you mix up Australia and Antarctica, you're not that wrong. These two continents used to be one. If you mix up Austria and Australia, it's much worse. By the way, don't fall for the internet myths and memes. There's no help desk in Austria specifically for people who intended to fly to Australia. Now, look at this magnificent Australian pink beach. It's precious, and not in a figurative sense. Those mysterious pinkish sands are actually garnet, and it's widely used in jewelry. Geologists studied those sands and came to the conclusion that the garnet contained there is older than local mountains. That doesn't make sense, right? In fact, it does. You see, Australia didn't used to be this very detached continent as it is now. Many, many millions of years ago, Australia and Antarctica were part of the supercontinent Gondwana, and glacial erosion released the garnet, which eventually made its way to the beach. These sands formed when South Australia was flat and chill, long before the mountains appeared. Most garnet gets washed away, but this batch has a rich history, tracing back to glacial rocks in the Transantarctic Mountains. So this pink sand comes from an ancient mountain range hidden under Antarctic ice. Not only does Antarctica ice hide gems like garnet, if you look harder, you might find entire buildings. Sounds insane, but this is exactly what a British explorer did. His name is Chris Brown, and he uncovered an entire building beneath the ice. He was traveling to the pole of inaccessibility, and it all started with a bummer. Chris and his son had their plane broken. Suddenly, they spotted a lone bust peeking out of the snow. This place was an old meteorological station. Despite freezing conditions, Chris and his son Micah had a blast exploring. Chris is on a mission to conquer all 7 earthbound poles of inaccessibility and has tackled 5 so far. I guess you already know that Antarctica is the largest desert on Earth, much larger than the Sahara or the Gobi. Still, despite being the driest continent on Earth, it boasts a seriously weird waterfall. Nestled in the mesmerizing McMurdo Dry Valleys, it's 5 stories tall and looks like it's gushing blood. It's even called Blood Falls. It may look outlandish and even frightening, but its nature can be easily explained. The water that creates this crimson cascade was once a salty lake, but over time, it became sealed off from the outside world when glaciers formed on top of it. Now, this ancient water hanging out 1,300 feet below the surface has cranked up its salt levels to 3 times saltier than the ocean. This salt water is also loaded with iron and gets 0 oxygen or sunlight. When the iron-rich water trickles through a crack in the glacier and meets the air, it rusts up, turning dark red. You may have mistakenly heard that no bug species belongs to Antarctica, but it's not exactly true, because there's this tiny Antarctic midge living there. Plus, There are some spiders too. Those aren't your average spiders hanging out in the darkest corners of your apartment. Those are critters lurking in the chilly darkness of the Antarctic ocean floor. These little marine creepers are actually arthropods and can stretch around 20 inches across. As if that wasn't bizarre enough, they also breathe through little holes in their legs. Quick question. What's the color that you associate most with Antarctica? I'm sure it's white. That's my association too. However, Antarctica may look like a slice of watermelon. That colorful snow comes courtesy of a tough little algae called Chlamydomonas nivalis. When things start to warm up during the Antarctic summer, these little guys release their vibrant red and green spores, painting the snow in wild and funky colors. But it's best to steer clear because that snow is not just a pretty sight. It's also toxic and definitely not edible. Searching for fossils is always a blast, but when you're in one of the most remote spots on the planet, it gets even more exciting. A diverse team of scientists recently hit the mother lode, pulling in over a ton of fossils from ancient marine life, dinosaurs, and birds from the late Cretaceous period, about 71 million years ago. Their adventure kicked off with a flight to South America, followed by a 5-day trek through the infamous Drake Passage. Upon reaching Antarctica, they set up camp using helicopters and inflatable boats. You might be thinking, why dig in Antarctica with all that ice? Well, it turns out there are places where rocks pop up, depending on the season. The team went to James Ross Island, located in the Antarctic Peninsula, and they went there during February and March. And that's one of the few parts of Antarctica where in summer, rocks are exposed, and those rocks can come from the age of dinosaurs. The expedition was a success, as they discovered over a ton of remarkable finds. Next up, the fossils will head to Chile before making their way to Pittsburgh's Carnegie Museum of Natural History. Among their discoveries, they found relics dating back about 71 million years, alongside some around 67 million years old, including plenty of snails, clams, and various marine creatures. Yikes! Look at this creepy sea worm. It could live in LA and be a star in a horror movie, but it chooses to call the chilly waters of the Southern Ocean near Antarctica its home. These worms can grow up to 8 inches long and 4 inches wide, but don't let their spooky exterior trick you. Research suggests they might actually be superheroes in disguise, playing a vital role in keeping ecosystems buzzing. Now, see that head? It's not really a head. It's just a retractable throat that helps this toothy creature chow down on its meals. Antarctica has many creepy critters to offer. Let me introduce you to the Antarctic strawberry feather star. It's not like Patrick from SpongeBob though. It's more like a deep-sea creature straight out of a horror movie. Picture this, 20 wiggly arms, some stretching up to 8 inches, all decked out with these bizarre little bumps. Yikes indeed. Back in 2014, scientists buried 34 seismic monitors in the snow on the Ross Ice Shelf, which is huge. Think of it as an ice slab the size of Texas, just chilling over the Southern Ocean. These clever little machines picked up a nearly non-stop buzzing. Even though our human ears usually can't catch these low-frequency sounds, scientists have worked their magic and made them audible for us. They even shared the creepy audio online. A glaciologist from the University of Chicago says that if you could hear this vibration, it'd sound like a swarm of cicadas taking over the backyard in late summer. But these glacier explorers weren't trying to capture spooky tunes. They're actually on a mission to monitor the Ross Ice Shelf because things are heating up, literally, and the ice is melting faster than ice cream on a hot day. Ice shelves are like Earth's safety plugs, keeping all that massive ice from surging into the ocean. So what exactly is making all that noise? It's likely just strong winds whipping across ice dunes, creating a kind of natural vibration. These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ancylonema alaskana and the Ancylonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it.
You know, those fluffy cumulus clouds you see in the sky weigh as much as a Boeing 747 or 100 elephants. Hey, if you don't believe me, let's do the math. Scientists figured out that the density of water inside a cumulus cloud is around 0.5 gram per cubic meter. Now, clouds come in all sizes, but an average cloud of this type is shaped somewhat like a cube and has a volume of 1 billion cubic meters. When you multiply it by density, you get an impressive result of slightly over 1 million pounds. And in case you were wondering, this giant stays afloat because its density is lower than that of the air surrounding it. Giraffes are 30 times more likely to get struck by lightning than you are. There were 5 official fatal cases involving giraffes and lightning between 1996 and 2010. But since their population worldwide is just around 140,000 during that period, the fatality rate is rather high per 1,000 of giraffes per year. Lightning bolts love tall objects, so giraffes are unfortunately an easy hit. But scientists think they might have learned to deal with it and seek shelter during a thunderstorm or move quickly to thickly vegetated areas. The oldest animals on Earth are glass sponges. They can live up to 15,000 years. Scientists found the oldest glass sponge in the Ross Sea, a part of Antarctica. In another part of the world, the East China Sea, scientists found the skeleton of a glass sponge that lived for about 11,000 years. These sponges might have been around during the last ice age. They lived their whole lives stuck to hard surfaces, filtering water to snack on bacteria and plankton. So, our Earth is spinning more slowly now, which means our days are getting a bit longer over time. Long ago, I wasn't around then, a day on Earth was only about 19 hours, but then it grew to 24, mostly because the moon's gravity pulls on Earth and slows it down. Different extreme things go on in nature that can change the speed of Earth's spin in the short term. An earthquake in Chile in 2010 may have made our day a little bit shorter, according to scientists. But since 2020, the days have been getting longer again. Now, scientists still can't decide if water is actually wet or not. Some of them say water isn't wet itself, but it can make other things wet when it sticks to them. Others think water is wet because it's a liquid and has moisture. Water can feel wet because it cools your skin as it evaporates. How wet something is depends on two forces: cohesive forces that keep water droplets together and adhesive forces that make water stick to things. Water doesn't stick well to waterproof fabrics, and they stay dry because cohesive forces are stronger in that case. Guess what? There is no map of the world that would be 100% accurate unless it's life-size. Our planet is round and paper is flat. Duh! Back in the 16th century, Gerardus Mercator designed a cylindrical map projection that is still used and named after him. This concept is good for navigation because the north is always up, but the top and bottom parts get stretched out. So Greenland looks 14 times larger than it really is, and Alaska is the size of Brazil. Around 4 billion years ago, Earth's atmosphere was very different from what we know and love. But volcanoes saved the day. Tons of them were erupting all over the place, spewing out carbon dioxide. This gas filled the sky and made up most of the atmosphere. Tiny early plants used that carbon dioxide to grow by photosynthesis and give out oxygen. One of the theories says that the steam from all the volcanoes cooled down and turned into water and gave us the oceans. It took about 2 billion years for enough oxygen to fill the air so that animals could live and breathe here. Now, if for some reason you ever decided to stack all the world's germs and bacteria on top of each other, they would stretch for 10 billion light-years. But you wouldn't even see this thread, because it would be about 75 times thinner than a human hair. If you wrap this long line of bacteria around our galaxy, the Milky Way, it would circle around it more than 20,000 times. Ooh, my brain! It turns out there's rust on the moon, and it may have traveled all the way from Earth to get there. Now, rust usually needs oxygen and water to form, and the moon has almost none of either. But when this celestial body passes through a part of space called Earth's magnetotail, oxygen from Earth can reach it with solar winds. This oxygen may have combined with tiny amounts of water and iron on the moon's surface to create rust. Now, even a tiny asteroid can knock our planet out of its orbit. But don't worry, you probably won't even notice any difference. The effect of an impact will depend on many things, like how strong the space rock is, how fast it's going, and what kind of ground it hits. Most of the time, when space rocks hit Earth, they break apart or turn to gas before they reach the ground. But big ones, like the one that wiped out the dinosaurs, can cause huge problems, like big waves, earthquakes, and even change the weather. The Earth isn't solid like a rock on the inside, but more like squishy clay because of the very high heat and pressure deep underground. This squishiness allows the mantle to move very slowly over millions of years, and that's why we get earthquakes, volcanic eruptions, and the shifting of continents. During the last ice age, huge heavy glaciers sat on top of Earth's surface, pressing down on the squishy mantle underneath. This made the mantle sink a bit. When the ice melted, the mantle started pushing back up, and the land began to rise again. Even today, in places like Canada, Greenland, and Scandinavia, the land is still rising because of this. Our planet is covered with cosmic dust. About 5,000 tons of it reach the surface of Earth every year. This interstellar substance is smaller than a grain of sand and often even thinner than a human hair. Scientists go all the way to the middle of Antarctica, where it barely snows, and the snow is super clean to spot those particles. Most of this dust comes from comets. If you're an introvert, Greenland is the ideal place for you. It is the least densely populated area in the world, with only 0.1 person per square mile. Wow, I've never actually seen a tenth of a person. Anyway, most of Greenland is covered in ice, so people live mainly along the west coast. Oh, and by the way, it's been inhabited for over 4,500 years, so it must not be that bad after all. Guess what? The ground you walk on is actually recycled. First, hot melted rock from magma comes to the surface and cools down to become solid rock. Then, thanks to tectonic forces, the rock gets pushed up to the surface. Over time, wind, rain, and other forces break pieces of the rock off. They get carried away and eventually settle down in layers. These layers get squished together, forming sedimentary rocks, like sandstone. Sometimes, if these sedimentary rocks get pushed deep under the Earth's surface, the heat and pressure cook them into a new type of rock called metamorphic rock. A long time ago, life on Earth might have been purple instead of green. A molecular biologist from the University of Maryland thinks that the very first microbes used a special molecule to capture sunlight that made them look purple. Today, plants are green because they use chlorophyll to absorb sunlight and turn it into energy. But before chlorophyll existed, retinal molecules did the same job. It soaked up green light from the sun and reflected red and purple light, which made the microbes look violet and like little tiny grapes. Really.
This sleek, state-of-the-art submarine named Ran was sent to explore the depths of Antarctica. But as soon as it discovered something, it mysteriously disappeared. So, what happened? It all started when scientists wanted to explore one of the most remote and mysterious places on Earth, the Dotson Ice Shelf in West Antarctica. This ice shelf, silent giant, stretches 30 miles wide. That's almost the length of New York City. It stands between two icy promontories, the Martin and Bear Peninsulas, and it hides an entire world of geological mysteries. If you think that Antarctica is nothing but a desert of super thick snow and ice, you're wrong. There are entire landscapes hidden deep down there. The underside of the Dotson Ice Shelf is a rugged, dynamic terrain shaped by the slow, relentless forces of nature. There are towering ice formations, deep troughs, and bizarre structures stretching for hundreds of feet. Scientists are super curious about it, but as you can imagine, this landscape isn't easy to explore at all. To find out more, we have to scan the area with satellites or try drilling through the snow, trying to collect the big picture, piece by piece. But these methods only gave us vague hints. The real breakthrough happened when scientists came up with the idea to let the submarines explore it. Autonomous submersibles could swoop deep into the icy waters beneath the Dotson Ice Shelf and tell us what's up down there. These robotic explorers have fantastic advanced sonar systems. It's that thing that bats or dolphins do. They can use sound to see the world. Basically, they send out sound waves underwater, and when those waves hit something like the ice shelf above or the seafloor below, they bounce back to the system. Animals feel how long it took for the sound waves to return and how they changed. And this helped them understand what's located where. For example, clicks that dolphins send out tell them where the fish are. We copied this crazy evolutionary trick and adapted it to our underwater exploration. Only our version is much cooler, with a higher level of precision, so we created detailed maps of the environment. The Rand submarine was one of those robotic explorers. It was named after the Norse deity of the sea. Ran had been meticulously programmed to navigate a treacherous landscape of Antarctica. But even with all this training, its journey led to an unexpected and eerie end. In 2019, Ran was sent to explore the depths beneath the Dotson Ice Shelf. It was a hero, the first one to go on a mission like this. The team said it was like seeing the other side of the moon. For 27 straight days, it worked tirelessly. It traveled over 620 miles beneath the thick ice. That's like a journey from Paris to Berlin. RAN went further and deeper than anyone could have imagined. At one point, it reached over 10 miles into the glacier's belly, and what it discovered down there was astonishing. Scientists thought there would be some smooth, uniform ice surfaces, but RAN revealed an underside marked by huge cracks, ridges. There were formations that looked like sand dunes, frozen in time. And finally, it found some mysterious swirling and teardrop-shaped patterns. They all looked more like art than geology. This actually tells the story of ice shelves and the ocean around it. Warm water sneaks in under the ice and melts it from below. Sometimes it smooths the ice out, but other times it carves out these weird, uneven shapes that look like patterns and drawings. And some of these shapes are huge, over 1,300 feet long. That's about 3.5 football fields. The reason why they look like swirling doodles is because the Earth spins. It makes the water turn in special ways, bending the shapes and drawing these spirals. It's called the Coriolis effect. Imagine you were on a merry-go-round and tried to throw something like a ball. It would go in a curve, not a straight line. Same thing happens with the water on Earth. Later, scientists found similar patterns in other Antarctic ice shelves, though they weren't as epic as the ones under Dodson. But RAN also discovered something horrifying. Turns out that these warm waters, aside from being great artists, are also a huge danger. The Dodson ice shelf isn't just hanging out serenely on the sea. It's part of a very delicate system and acts as a protective barrier that holds back huge glaciers in West Antarctica. The ice shelf is floating on the ocean, but it's still connected to the land. As warm water sneaks underneath it and the ice melts, the Dodson can't hold on to the land as tightly anymore. The protective barrier starts to weaken, and this lets the glaciers behind it move faster into the ocean. When those glaciers flow into the sea, they add more water, which could cause sea levels to rise, eventually changing our coastlines. RAN stumbled upon huge pockets where the ice was melting at alarming rates, all due to powerful underwater currents. It was like seeing a ticking clock on the glacier. The stakes were high, but luckily the submarine was ready. This time, it managed to return. And then, it worked for 5 more years, helping scientists with tons of useful data. The missions were daunting. There could be periods where RAN slipped into the pitch-black cavity beneath the glaciers, spending 24 hours without communication. But it was mapping every peak and every valley. It gained experience from over 40 missions below ice. Then, in early 2024, RAN went on a mission to the Thwaites Glacier. The mission was bold from the start. This place is also ominously referred to as the Doomsday Glacier. It's called that because it's slowly melting and has the potential to raise sea levels worldwide if it collapses, causing catastrophes everywhere. That's why RAN was dispatched to explore its underbelly, a place that had never been mapped so intricately before. The idea was to uncover the glacier's secrets, study how rapidly it was melting and why. This was RAN's second time exploring Thwaites. During the previous visit, it became the first sub to ever map the glacier's underside. RAN was exploring the depths from 650 feet to 1,650 feet. It sent a lot of data about how the Doomsday Glacier was slowly melting due to warm ocean currents. But while venturing into these icy depths, something went wrong. Out of nowhere, RAN vanished. Without warning, without a trace. One moment it was sending back crucial data, and the next, it had slipped into the abyss. No distress signals, no final transmission, and it didn't return to the point it was supposed to. People sent extensive searches, helicopters soared overhead, drones buzzed through the frozen skies, but no sign of the submersible emerged from the glacier's grasp. After a while, RAN's batteries would certainly run away. So at this point, it had definitely been swallowed by the abyss beneath 1,500 feet of ice. That was a huge and sad loss for the scientific team. The scientists at the University of Gothenburg are now looking to replace RAN, and continue their important research under Thwaites. To this day, scientists have no idea what happened to it. Some say it may have been trapped in the ice. Others believe it was pulled away by an unseen current. It also might have collided with something unexpected. Whatever the truth is, its disappearance has left scientists stunned, and it looks like the ice shelf will hold on to its secrets a little longer. At least we gained a treasure trove of knowledge from Rand's journey. Scientists keep exploring Antarctica, looking for history that hides under the snow. For example, they discovered that around 90 million years ago, a lush temperate rainforest thrived near the South Pole. They revealed an ancient world far warmer than they ever imagined. Deep in Antarctica, they unearthed fossilized roots, pollen, and spores preserved in the soil. All this shows that there was a swampy rainforest that flourished despite months of polar darkness. All these discoveries changed our understanding of Earth's climate, both in the past and the future. You're down in one of those polar seas where the Brinicle, eerily called the Finger of Death, is born. It's a strange, almost otherworldly place, the deep ocean, where light barely reaches. Everything down there seems to have adapted to survive in darkness and intense cold. But even those truly hardy creatures aren't ready for what a Brinicle can do. When that briny, supercooled water starts dripping down, a ghost story begins. The formation of these brinicles is a fascinating process, like an underwater science experiment happening in real time. We know that when seawater freezes, it doesn't freeze like fresh water. Because of all the salt in it, it has to push out impurities to form the pure ice that floats at the top. This means the salty water, or brine, ends up trapped in channels and pockets within the ice. When it sees the light of day for the first time, a brinicle resembles a pipe of ice reaching down from the underside of a layer of sea ice. At first, a brinicle is very fragile and its walls are thin. But the continuous flow of colder brine supports the growth of the brinicle. It also prevents it from melting. Otherwise, this process would be inevitable, caused by the brinicle's contact with less cold surrounding water. As the ice accumulates and the walls become thicker, the brinicle becomes more stable. Over time, the brine trapped inside gets squeezed out through tiny cracks, dripping down in this cold, heavy plume. Once that cold brine starts flowing downward, it begins freezing the seawater around it into a sheath of ice. That's why, instead of melting as it hits the water below, it forms this icy casing that protects it, helping it grow longer and stronger. The brinicle keeps moving forward inch by inch, and this crazy downward spiral is almost unstoppable. And when it touches down on the seafloor, that's when the trouble begins for anything living nearby. Imagine being one of those creatures on the seafloor, maybe a sea star or an unsuspecting urchin just trying to make it through the day. And all of a sudden, you see this icy tentacle nearing you. It isn't just some cold water coming down. It's basically a net of ice moving down and spreading out. There's no escape, no way to predict its coming, and no chance for survival. It's a slow-motion natural disaster in action. When a brinicle reaches the seafloor, it continues to accumulate ice while the surrounding water freezes over. The brine keeps traveling across the seafloor in a downslope direction. Once it reaches the lowest possible point, it stops and pools. But don't let the danger distract you from how beautiful brinicles are. Well, in their own creepy way. They look like something you'd see in a dream. Elegant, twisting ice tubes reaching down, perfectly symmetrical, and totally random. Filming a brinicle is no easy task because they're delicate when they first form. Just the motion from a nearby current or a sudden change in temperature can snap them off, ending the show before it really starts. So, scientists who managed to capture brinicles on film in 2011 actually got incredibly lucky. It was the first time the world got to see this icy finger descending and freezing everything it touched, and it changed our understanding of polar ecosystems. Brinicles can reach quite impressive sizes. Sometimes they can stretch for several feet. Their size depends on the conditions of the water and ice above. The slower the water movement and the colder the temperature, the bigger and stronger a brinacle can grow. But if the water's too deep or if there's too much movement in the current, the brinacle is likely to break apart. It needs just the right balance to survive long enough to touch down and freeze over the ocean floor. For creatures living on the seafloor, brinicles are like invisible booby traps, only instead of avoiding a net, they're avoiding an expanding ice cage. Starfish and sea urchins might not have big brains, but they have a basic survival instinct to crawl away from danger. Sadly, with brinicles, they're usually caught completely off guard. One second they're minding their own business, the next, an icy sheet is closing in around them, trapping them where they are and freezing them almost instantly. It's hard not to feel sympathy for these creatures, right? You watch footage of a brinacle in action and you see a starfish just stopping. One moment it's moving slowly along the sand, and then it's frozen in place, totally helpless. It's like watching a train wreck in slow-mo. Luckily, brinicles present danger only to smaller marine life forms like sea urchins and starfish. Bigger animals like seals or whales, or humans who happen to go diving in the ocean at the frigid poles, brinicles are totally harmless. At the same time, for scientists, this tough natural phenomenon offers a fascinating insight into how life adapts, or fails to adapt for that matter, in extreme environments. And it gets even better. A brinacle might just be the perfect setup for life to begin. Researchers are now looking at these super salty ice tubes as not just fatal traps, but potentially as sources of life. This theory isn't just science fiction, it's rooted in actual research. Here's how it goes. The brine channels in sea ice are full of tiny, confined spaces. Those are exactly the kind of places where chemicals can get trapped, concentrated, and start interacting in interesting ways. It's like setting up a mini-lab where the building blocks of life can come together and create something new. Scientists think this process of salt rejection in sea ice could have actually helped the first bits of life appear. Some researchers even think that this process might be happening right now on icy moons like Europa, Ganymede, or Enceladus, where there might have been frozen seas beneath thick ice layers. Just imagine it, brinicles forming in other worlds of our solar system, laying down the foundations for extraterrestrial life, and all thanks to the same icy process that creates these fingers of death here on Earth. One way scientists describe brinicles is by comparing them to chemical gardens. Have you ever done one of those experiments where you mix metal salts into a solution and watch them produce plant-like structures? Well, you can observe a similar chemical process when a brinacle is in action. In the cold, saline-rich brine of a brinacle, certain reactions could kick off to create amino acids or other building blocks of life. It's wild to think that something so dangerous could have also helped shape our world, or could be creating other forms of life elsewhere. In both cases, whether on Earth or another planet, these icy chemical reactions might be the first step toward the formation of simple life forms. It's a kind of alchemy, where ice and salt water mix to create something more than the sum of their parts. This is one reason why scientists are so eager to study brinicles. Each one could hold a tiny clue about how life begins, survives, or fails under extreme conditions. Something as mesmerizing and weird, but at the same time simple as brinicles, hints at bigger questions. How did life start on Earth? What are the conditions needed for life to survive in extreme environments? Could icy structures like these exist in other parts of our solar system or beyond, creating similar conditions that might one day give rise to alien life? As much as they look like a silent threat reaching out from the ice, brinicles are also reminders of how beautifully complex and interconnected our world is. They may seem like simple fingers of ice, but they hold secrets that touch on everything from ecology to chemistry, to the origins of life itself. So next time you hear about the ocean, remember that deep below in the darkest, coldest waters, something incredible and a little bit terrifying is happening right at this moment. Look at that! What is that perfectly shaped ice circle doing in the middle of the river? How did it even appear there? For such a circle to form, the conditions must be very peculiar. So let's see if you can make a similar ice formation at home. Ice circles are also called ice disks and ice pans. They form in rivers, lakes, and creeks when ice gathers in the center of the body of water moved by an eddy. The thing is, random eddies tend to follow circular routes. And in the winter, ice crystals often gather in such slow-moving waters. As a result, they form circular disks of ice. The current doesn't let these disks move away, it just slowly rotates them in one place. As an ice circle turns, it hits other chunks of ice or the shore and gets lathed down until it's perfectly round. There's another way for ice circles to form. When a body of water gets covered with ice, a current traveling underneath might break off a chunk of ice and start rotating it until it's shaped like a circle. These disks can be really large, up to 50 feet across. Another amazing ice phenomenon is called penitentes. These are snow formations found at very high altitudes. Numerous and closely spaced, they look like long, thin blades of hardened snow or ice that point towards the sun. These icy spires grow over snow-covered and glaciated regions in the dry Andes at a height of more than 13,000 feet. Some penitentes are just several inches tall, while others reach 16 feet. That's around 3 human heights. Such jagged structures form due to the process called sublimation. It's a bit similar to melting, but in this case, the sun turns the snow directly into vapor without melting it first. In other words, the ice skips the liquid stage and goes from its solid form to gas. Curved areas of the surface heat up and sublimate faster than others, forming dents. That's how penitentes get formed, and that's why they lean in the direction of the sun's rays. Now, this is called rabbit ice. And isn't it cute? This phenomenon has other names too. Ice flowers, ice wool, ice ribbon. Pick whatever you like. I'll stick to rabbit ice. It forms when the air has cooled down to freezing temperatures. But the ground hasn't frozen yet. Sap in the plant stems expands while freezing, and it causes cracks along the stem. What happens next is water gets drawn out through these cracks. It freezes once it comes in contact with the air. This process forms super thin layers of ice, creating something that resembles ribbons or petals of ice. The same phenomenon happens with woody plants, but in this case, the ice is even thinner, more hair-like. These ice formations are incredibly delicate, so if you want to see rabbit ice, look for it in the early morning in shaded areas. You can find frost flowers floating on the surface of a newly frozen lake or sea. In 2009, a team of scientists from the University of Washington was sailing near the North Pole. That's when they discovered a large field of these pretty ice formations. But the best thing was that when they melted a few of these blossoms, they noticed that the water contained an unusually large number of bacteria. But how do these amazing ice formations appear? The air must be extremely cold, colder than the surface of the ocean, and very dry. When the air is so different from the ocean, its dryness pulls some moisture out of the water. The air gets humid, but just for a while. The cold makes the water vapor heavy. No wonder the air wants to get rid of this additional weight. So, crystal by crystal, the air turns back into ice, creating delicate flowers, sometimes reaching up to 3 inches in height. The ocean literally blossoms. Needle ice also has many names, and the most creative of them are frost columns, ice fringes, and ice castles. This type of ice occurs in a similar way to rabbit ice, but the water gets drawn out from the soil surface through narrow capillaries. All this water freezes in needle-like columns. At first sight, these formations look like baled hay, but made out of snow. And actually, it's quite an accurate description. You know how hay gets rolled up into large balls? Well, the same way snow rollers form. The wind blows a chunk of snow along the ground. As it rolls, it picks up even more snow, growing in size. Snow rollers are usually cylindrical and hollow inside because the very first layer of snow often flakes away as the roller moves. These snow formations can get up to 2 feet in diameter. They occur when the temperatures are near melting and there is a fresh layer of fluffy snow on the ground. Oh, and it shouldn't stick to the surface it lies on. Don't forget about the wind either. It should be strong enough to make the roller, well, roll, but not too strong to break it apart. These conditions sound rather precise. That's why snow rollers are so rare. But it's not only ice that creates amazingly beautiful things. Fire can do it too. Look at Pele's hair. These thin threads may look golden and pretty, but they're very dangerous to pick up. The wind sometimes catches small droplets of lava coming from active volcanoes. These droplets get carried miles away from the vent and are stretched into super thin glass wires, also called hair lava. Some strands can be as long as 6 feet. Have you warmed up yet? Then it's time to cool down again. On March 19, 2018, the inhabitants of Alabama had to run for their lives not to be hit by huge chunks of ice falling from the sky. It was the infamous hailstorm of Alabama, which caused millions of dollars worth of damage. After the hailstorm, it looked as if the place had been thoroughly trashed by savages. Broken shop windows, smashed car windshields, broken billboards, and holes in roofs. But what made researchers really excited was a hailstone found near the town of Cullman, Alabama. This softball-sized monster was more than 5 inches across and thus set a new state record. Now, look at these pretty bubbles. They're pockets of highly flammable and combustible methane gas. Trapped underwater, this gas forms psychedelic landscapes and stunning patterns. Typical for northern latitude lakes, such as Lake Abraham in Alberta, Canada. These bubbles appear when animal remains, leaves, and plants fall into the water and get consumed by bacteria. These bacteria later excrete methane gas. But don't fall for the beauty of this phenomenon. When spring comes, the ice melts and the methane bubbles start to fizz and pop in a most amazing fashion. But if you happen to light a fire in the area, everything may go boom. Imagine surfing a perfect wave when it suddenly freezes. Well, it sure sounds creepy. Luckily, such things don't happen in life, right? Wrong. You can see mind-boggling frozen waves in Antarctica. These waves occur when the ice gets compressed and the ever-increasing pressure squeezes the air bubbles out of it. As for the beautiful blue color, it's the result of the ice melting and refreezing. And a bonus for you, frozen Niagara Falls. In 2018, the legendary waterfalls, located at the border between New York State and Ontario, Canada, managed to shock everyone into silence. Tourists who arrived to admire the power of the roaring water were astonished to find Niagara Falls frozen. Jumping ahead of myself, the waterfalls weren't frozen per se, since such a feat is impossible for a mass of flowing water that huge, but microscopic water droplets that got airborne off Niagara Falls, as well as the mist, formed a crust of ice over the rushing water. As a result, you could be looking at the waterfalls and be sure that they were frozen. In reality, the water kept flowing, but it was hidden beneath the ice.
Phew! This summer has been turning up the heat like never before. We feel like roasted marshmallows on a sizzling grill. Yes, the world is getting hotter, but some regions have always fought with high temperatures. It turns out people had some inventions to keep themselves cool in ancient times too. Some of them are still functioning, even 3,000 years later. Let's take a look at how people saved themselves from heat throughout history. So, put an ice cube into your cold drink and get ready to hear how people survived the heat. Speaking of ice cubes, do you know that the Persians made an ice storage system? In the deserts of ancient Persia, people had an out-of-the-box idea about how to prevent their food from turning into a melted mess. These ingenious Persians stumbled upon a physics trick that allowed them to create ice in the middle of the desert. They called these cool structures yakhchals, which basically means ice pits. These ice pits were not your ordinary coolers. They were like secret underground fridges. They looked like dome-shaped mud brick structures on the outside, but inside, it was a whole different world. These ice pits had an evaporation cooler system that worked like magic. At night, when the desert cooled down, Persians made use of the radiative cooling effect. They set up cleverly designed trenches to hold thin layers of water. The water froze, defying the desert heat. Then there were underground square storage areas. The Persians collected the melting ice water from these cooled trenches, and during the night, they froze it again, making the most of the desert's natural chill. To add to the cooling effect, they built a wall to shade the storage areas from the hot midday sun. And that's not all. They had this fantastic wind-catching contraption called a badger that caught the breeze and directed it right into the ice pits. Fresh air plus ice. Cool breeze. A winning combo. They even had intricate water channels called qanats to bring water to the ice pits and homes all the way from the nearby mountains. As time passed, these yakhchuls faded into history and modern technology took over. But hey, there's good news too. Some awesome folks in Iran are restoring these ancient coolers. So, if you ever find yourself in the desert, don't forget to pay a visit to these marvelous places and witness the genius of the ancient Persians firsthand. Now, I want to focus more on the wind catchers because they don't just help make ice cubes. They actually function as a cooling system as well. Back in the day, those clever architectural wonders were all the rage in places like Persia, modern-day Iran, Egypt, and the Middle East. Imagine tower-like structures with openings at various levels strategically placed to harness the power of nature's breeze. These openings were like magical portals for the wind. They captured those refreshing gusts and guided them right into people's living spaces. Basically, they were natural air conditioners. The breeze would gracefully flow downward, cooling the ground as it danced through the building. The secret sauce lies in the details. The tower's height, the number of sides, the openings, and the positioning of the interior blades. Everything plays its role in how efficiently the wind towers work out. Thanks to these wind catchers, ancient societies could enjoy comfy indoor temperatures without sweating. Can you imagine living in those times? Feeling the gentle breeze whisking through your home, keeping you feeling fresh and chilled out? The Persians are often credited for inventing these awesome wind catchers. But hey, don't forget about Egypt. There, you can find traces of similar structures dating all the way back to 1300 BCE. Yes, the invention of wind catchers may have occurred in ancient Egypt, but Yazid in Iran is the city with the largest number of wind catchers. People wouldn't have been able to live there without these ancient ACs because there was almost no rain in the area throughout the year. Now, let's look at these perforated double-skinned exteriors. Imagine dressing up a building with a fancy perforated screen. It's like giving its exterior a stylish makeover while keeping things chill inside. This genius technique, firstly, scatters the natural daylight, so no harsh sunbeams to blind you. The screen also offers shade like a pro, giving the building's interior a much-needed break from the blazing sun. Think of it as a natural sun hat for your home. Placing this screen about 4 feet away from the outer walls creates a breezy, dreamy hallway for fresh air circulation. And hey, they add a touch of elegance to the building too. These structures are sometimes called jali. Jaipur, India, for example, has an average daytime temperature of about 100 degrees Fahrenheit. So these structures are lifesavers. Jalis come in various forms, crafted from cement, earth, and wood. It's a cultural symbol deeply embedded in Indian architecture. You can find its captivating presence in iconic historical buildings like the majestic Taj Mahal and the Grand Red Fort in Delhi. But hey, it's not just a thing of the past. It's still rocking modern architecture scenes, and its charm has sparked creativity in artists and designers worldwide. It adorns the building's exterior, its cross-section showing a larger opening on the outside and a smaller one on the inside. This is where the Venturi effect steps in to show off its physics prowess. As the air flows through the narrowing passage, it picks up speed, creating a difference in pressure between the inside and outside of the building. Air blowing at a higher speed gets compressed, and when released, it cools down. Mashrabia is a wooden lattice or screen used in the Middle East and North Africa. These decorative wonders are like window blinds, But they do more than just look pretty. They're smart too. They give privacy, shading you from the sun, and let fresh air and light in. Some people also add clay pots filled with water, sand, or damp straw to their designs. As hot air breezes through the holes, it also passes through the pot's porous surface. The moisture inside evaporates, cooling the air. This is a perfect low-cost technique for hot and dry climates. It's eco-friendly, and there's no need for electricity. Now, let's fast forward to today. Designers are getting creative, mixing traditional wisdom with modern tech. At the Al Bahar Towers in Abu Dhabi, they've got it too. Picture over 2,000 hexagonal panels that dance with the sun's movement, providing shade to the building's interior. Water evaporation was another secret weapon for ancient people. Simple, yet super effective. Plus, ancient Egyptians hung wet mats and curtains in doorways. When the air passed through them, it cooled down, providing a relief from the scorching sun. Ancient architects were the masters of maximizing airflow. They knew how to cross-ventilate and let hot air escape while inviting cooler air to the party. Speaking of ancient Rome, bathhouses were the place to be back then. It was like a community hub. People gathered to chat about politics, play sports, and, of course, take a relaxing dip. The frigidarium was the cool spot in Roman baths. After a steamy soak in the caldarium, Romans dashed to this giant pool to chill out. Then in some places, like Cappadocia in Turkey, people went underground to hide from the heat. They carved cozy dwellings in volcanic rock, harnessing the Earth's natural cooling powers. So the lesson here is simple. Architects and designers can create wonders by combining local traditions with smart tech. California's Death Valley boasts the highest officially registered temperature to date, with 134 degrees Fahrenheit in 1913. Meanwhile, Africa's sweltering record stands at 131 degrees Fahrenheit in Kebili, Tunisia, as noted in 1931. In Europe, the highest temperature ever documented reached almost 120 degrees Fahrenheit in Sicily in August 2021. Then, in 2022, the UK had the hottest summer of all time.